All right, Hassler here. I didn't want to leave you hanging since I was out today, so I thought I'd do a quick video on making sure that you are good to go on practicing these 6 new derivative rules. All right, so just as a reminder, the derivative of sine of x is cosine of x. The derivative of cosine of x is negative sine of x. The derivative of an exponential with a base a is a rewrite of that function, a to the x, natural log of the base. Sorry for those funny a's. Versus the derivative of e to the x. Well, e is a special base, so e to the x, and then natural log of e, but we said natural log of e is 1, so just e to the x. All right, for log base a of x, that derivative is 1 over x, natural log of the base. And again, natural log of x already has a base of e, and so it turns out that the derivative of natural log of x is 1 over x. And these are things you just need to know and have memorized. And I don't have any tricks of the trade for you in terms of memorizing them, other than literally writing them down 10 times a day, or 10 times at a time, 3 times a day, until you memorize them. Other things that I did want you to get down, though, are things like what natural log of 1 is, and natural log of 1 is 0. Natural log of 0 is undefined. E to the 0 is 1. Anything to the 0 power is 1, except 0 to the 0. And then other fun things like e to the natural log of a. Well, the base of e and the base of natural log, which is e, they undo each other, so you're just left with a. And then natural log of e to the a is just a. Again, the base of the exponential and the base of the log undo each other. So there's just some bonus things to keep in mind. So I'm just going to do like one of each here for you so that you have something to think about and work on. And so I'm going to go ahead and do number 4 in this set of problems. So if I'm finding the derivative, I need to indicate that by writing g prime of x. All right, anytime I have a coefficient with a function, I'm just going to rewrite that coefficient. Right, we talked about that the last 2 days. And then I'm going to write the derivative of the function. So the derivative of cosine is negative sine. Now, personally, I like to put the negative out in front of any coefficient that is already there, right? This is really coming from the fact that you have 2 times negative sine of x, and 2 times a negative is just negative 2. This is my final derivative. Sorry, I lied. That is not my final derivative because I still have to take the derivative of 7e to the x. And so again, I'm just going to bring the coefficient along for the ride, and the derivative of e to the x is e to the x. This is my final derivative, okay? So your job is to do 1, 2, 3, 5, and 6. Let me do one of these down here. So you got 7, 8, and 9. So something like 7, it says find the value of the derivative at a given point. That's fine, I'll do 7. So the first thing I would have to do is I would have to find the derivative. And the derivative of natural log is 1 over x. So I have the 3 that's coming along for the ride times 1 over x. And then I have the derivative of e to the x, which is e to the x. By the way, 3 times 1 over x could just be written as 3 over x, okay, plus e to the x. That's my derivative, but I have to evaluate at 5. And so my next move is going to be, oh, what's a fun color? Oh, we'll go with this green here. My next move, and I'm in my next box, I apologize, but now I have to do f prime of 5. And so I'm just going to replace each x with 5. So I get 3 over 5 plus e to the 5, and that's my final answer. So that's what you're doing for 8 and 9. Something like 10 and 11 is finding the equation of the tangent line. So you're going to work through the same process we did in 7, and what you're doing in 8 and 9 as well. You're going to, find f prime of pi halves by first finding f prime and evaluating at pi halves. You have to evaluate the original function at pi halves. Then when you're done, you're going to write the equation of the tangent line, right? You're going to write, y minus, whatever you get when you do f of pi halves, I need an actual number here, okay? Evaluate that. Equals, well, whatever you get when you evaluate the derivative at pi halves. I want an actual number here. Evaluate that. And then x minus the pi halves. So you're going to do that for 10 and 11. And 12 and 13, we've talked about this. We talked about the fact that this indicates that you are finding f prime of x, and it's asking you to do specifically when x is 3, right? This says I'm going to find f prime of x. And it looks like I'm doing that specifically when the a value is pi 6. And so that is your job, okay, is to pick out the function, find the derivative, and evaluate at the specific a value. All right, if you have any questions, make sure that you identify what those are and ask me tomorrow in class. Thank you.